Okay, so let's talk about the big idea when we're finding exact trig values. And I'm going to go ahead and just move this out the way. But let's talk about the big idea when we're finding exact trig values. Number one, all exact trig values are the same. Number two, you just need to remember the trig values for quadrant one angles. As long as you remember those trig values, you know all of the exact trig values. Number three, we're going to find a reference angle and match the trig values for the angle in quadrant one. And we're going to do this in a couple of the practice problems so you guys know exactly what I'm talking about. Remember, the reference angle was the distance between the terminal side of the angle and the x-axis. And number four, we're going to change the sign based on what quadrant the angle lies in. And remember, when we talk about changing the sign, we're actually talking about changing the sign of the trig function based on the quadrant. So we're talking about changing the sign of the trig function based on the quadrant. Okay, whatever the trig value is, we're going to change it based on its quadrant. All right, so let's move on to the next slide. And this is where we're going to actually put this to practice. Now, what I want to do is I do want to change some of these into degrees, because when you go onto your Khan Academy assignment, you are going to see some of these angles in degrees as well. So I want you to be very comfortable with doing it in degrees and doing it in radians. I will focus on numbers 1, 3, and 5. So we'll do numbers 1, 3, and 5 together, and you are going to do the rest of these problems by yourself, and then you'll move on and you'll do the Khan Academy assignment. All right, here we go. Number 1 says, let's find the sine of 5 pi over 6. So what we're going to do is we are going to find a reference angle for 5 pi over 6. Now the reference angle, and I'll just say FR, reference angle for 5 pi over 6. Remember, in radians, we know that it's whatever it's over. So this is going to be pi over 6. So I can sit and I can just think about, hey, what is the sine of pi over 6? And if I know the sine of pi over 6, then I just need to think about where 5 pi over 6 lies, what quadrant it is in. And then I can just change the sine value of the trig function based on the quadrant. So the sine of pi over 6, we know, is 1/2. All right. And then we just have to think about what quadrant does 5 pi over 6 lie in. Well, 5 pi over 6 is in quadrant 2. That is the pi over 6 angle in quadrant 2. So that means that the sine of 5 pi over 6 is going to be 1/2. And I know in quadrant 2, the sine values are positive, so the sine of this is going to be positive. It'll be exactly the same. So the sine of 5 pi over 6 is 1/2. All right, let's go to number 3. They want the sine of negative 5 pi over 4. Now, I'm going to take a second here, and I just want you guys to think about negative 5 pi over 4. That is something that is not on the unit circle. So what we're going to do with negative 5 pi over 4 is we are going to find a coterminal angle. Do you remember finding coterminal angles? Okay. Coterminal angles. Okay. With our coterminal angles, we had to add or subtract 2 pi. If we were in degrees, we would add or subtract 360. So if I have a negative 5 pi over 4, I am going to add 2 pi to that, which means that because I want a positive coterminal angle on the unit circle, which means what I'm really adding is 8 pi over 4. Remember, I have to have common denominators when I'm adding. So 2 pi is just 8 pi over 4. So that means that the positive coterminal angle is 3 pi over 4. Okay. And let's think about it. 3 pi over 4 on the unit circle is in quadrant 2. Now remember, this is coterminal with 5 pi over 4. So the sign of negative 5 pi over 4 is the same as the sign of 3 pi over 4, which is in quadrant 2. So let's think about it. Pi over 4, the sign of pi over 4, which is our reference angle, right? We want to start with our reference angle. And we know our reference angle is pi over 4. So we got to think about what would the sine of pi over 4 be. We know that sine of pi over 4 is equal to radical 2 over 2. That means that the sine of negative 5 pi over 4 is going to be the same, radical 2 over 2. But we know since negative 5 pi over 4 is in quadrant 2, we know that the sign is going to be positive, right? Quadrant 2, the y values are positive, so the sign is still positive. So it will be the same. Radical 2 over 2, we do not have to change the sign. I'm going to clear out my drawing so that way we have more space. I'm going to go over to 11 pi over 3. All right. So let's talk about the sine of 11 pi over 3. And if you think about the unit circle, you think about our pi over 3 angles, we know that 11 pi over 3 goes past what's on the unit circle, all right? So we need to find a positive coterminal angle so we know exactly which quadrant 11 pi over 3 is in. So I'm going to move over here and do some work. Our coterminal angle for 11 pi over 3 means that this time, instead of adding 2 pi, we have to subtract 2 pi, right? And remember, we need a common denominator. So we're going to take 11 pi over 3. And what we're really subtracting is going to be a 6 pi over 3. All right. And if I take 11 pi over 3 minus 6 pi over 3, I know that that equals 2. That equals to our 5 pi over 3. And so we know that 5 pi over 3 and 11 pi over 3 are coterminal, meaning they stop in the same spot. So that means that 11 pi over 3 is going to be in quadrant 4. Let me go ahead and clear this out so we have some space here. So since this is going to be in quadrant 4, I'm going to go to my next step, which is thinking about what is my reference angle here. Our reference angle for 11 pi over 3 is pi over 3, right? So I am just going to think about what the sine of pi over 3 is. And I know that the sine of pi over 3 is radical 3 over 2. So I know that the sine of 11 pi over 4, or I'm sorry, 11 pi over 3 is going to be exactly the same. It's going to be radical 3 over 2. And I got to think about, my exception is I got to think about what happens to the sine values in quadrant 4. Well, we know in quadrant 4 the signs are negative. The only thing that's positive in quadrant 4 is cosine. So that means that this sine value, it will be negative. It'll be radical 3 over 2, but it is going to be negative. Okay? And that is the answer. All right, let's go to this last one. I want to do number 4 with you, and I want to show you what to do if, say, this was in degrees. So we're going to just do a little conversion here. Think about what is 3 pi over 4 in degrees. If you said 3 pi over 4 in degrees was 135 degrees, you are correct. And the reason why I want to put this in degrees is because you are going to get on your Khan Academy some angles in degrees. So let's talk about this. If I'm finding the cosine of 135 degrees, this is something on the unit circle. We don't have to find a reference angle, or I mean, not a reference angle. We don't have to find a coterminal angle, but we're still gonna use our reference angles to figure out what the sine and cosine is. So if I think about it, what is the reference angle for this? Well, remember the reference angle is the distance between the x-axis and the terminal side. So I'm in quadrant 2 if I'm at 135 degrees, which means the x-axis would be 180. So how much more do I have to add to 135 to get 180? And if you're itching to say 45, you are absolutely correct. We know that 45 degrees is our reference angle. So that means that if that's our reference angle, I can just think, hey, what is the cosine of 45 degrees? That is just pi over 4. And I know that's going to be radical 2 over 2. Which means the cosine of 135 degrees, or 3 pi over 4, has to be the same, radical 2 over 2, except we know since 135 is in quadrant 2, my cosine values have to be negative. So this is going to be a negative radical 2 over 2. I hope you all are seeing the big picture, which is that, hey, I don't have to know the whole entire unit circle. I only need to know quadrant 1. And then as long as I know the sine and cosine values for quadrant 1, I know the sine and cosine values for any of my special angles all the way around the unit circle. So I hope you guys are getting the big idea with that. And I hope you're getting more comfortable finding exact trig values without the unit circle. It's going to be very, very, very helpful as we move into tomorrow's lesson, where we'll be reviewing inverse trig functions. All right, guys, have a good day.